Welcome. In this video, we will talk about vectorized string operations in pandas. So this exercise uses this dataset, which is looking at a couple of companies' earning calls data. And in this dataset, as we have seen, the biggest column is the column text, which basically includes the whole text of each one of the earning calls. So for instance, if you want to take a look at the first text, we can do data.ilog 0, 1, because we want to look at text, and that's the text. If we print this, you'll see that we have a full transcript of the earning call transcript. Okay, so there is a lot of things that we can do with such a large quantity of text in the data. In this exercise, we'll be scratching the surface and doing some kind of aggregate statistics, and we will reconsider this data set in the future when we talk about text mining. So let's take a look at the questions. Question number 1 is asking us to report the most verbose sector, or the sector that uses more words than others on average. So if you take a look at this data frame, you can see that we have information about the sector as well as the company and the timestamp. Okay, so in this particular data, we have a bunch of sectors. Let's see what sectors we have here, sector, and let me do count. Excuse me. We should have grouped the data by the sector, because we've got 10 observations from multiple sectors, so we can either group by count, or we can call the function unique, which will give us the unique sectors in this data frame. So we have data from consumer services, technology, capital goods, finance. All right, so to get to the most verbose sector, we want first to count how many words are there in each one of these earning calls, in each one of these text observations. Okay, so if we have a piece of text, let's go back and pull the text from the data frame. I'm going to do data.ilog again, 0, 1. That's the text, right? If I want to count the number of words, remember that we used to split based on the white space, and then we do len, and this will give us the number of words in this text. Now it's possible to do this by writing a function that basically does that. So we can pull that text column from the data and then apply the function that will take the split and take the length. And you can see that I just copy and pasted what I had here, because my function will take any x, split, and then pass the result to len. This will give us the number of words in each one of the text. Okay, so we can save this one as a new column called words here. And then if we look at our data set again, we will have this piece of information. And then we can simply do group by, because I'm interested in sector, in reporting the average number of words per sector, right? So if I take a look at my words, I can calculate the average number of words, but this is not grouped by, this is the overall average. I want to group by this average by sector. So what I'm going to do, I'm going to group by sector, take words, crunch the mean. Alright, so we get the average number of words per sector. We're almost there, but not quite, because it's asking us to report the most verbose one. Right? So just kind of eyeballing the data, it seems to be actually technology actually. On average, we've got 9,570 words. So we want to implement this operation, and since it's asking us to report to the most, the sector that has most words, it makes sense to sort this data. Now notice that we've got here a series. The index is basically the sector, and the values are the average number of words. So I'm going to call the function sort values, and sort values will sort in an ascending order by default, right? So we got technology here. So that's fine, I can do that, or what I can do instead, I can do ascending is false, and I will get technology to the end. Either way, when it's sorted, I need to pull the last observation if it's ascending, or the first observation if it's descending. So to pull the last observation, I can do the index at -1 here, and this will give me the value pertaining to technology. But I'm not interested in the value that is related to the average number of words. I'm interested in the index itself. So what I need to do here is to pull my index, and that's the index here, and pull the last item in the index at -1. And this will give me back technology here. Okay? So the point in here is that we created a function that operates on text, and then we applied it to all the text entries in the series using the apply function. Now pandas offers what we call vectorized string operations or functions, and basically those are functions that will operate on all of the items in a series, provided that all these items are text. What's nice about the vectorized operations is that first, they're faster and more optimized than regular string operations, and second, if some of these entries are missing or are non-text, they know how to kind of gracefully handle these exceptions. Whereas in our case, if say one of these was none or not available, we would have gotten an exception that we then would have needed to deal with ourselves. Okay, so let's keep this in mind. I'm going to reload the data and repeat the same operation using the vectorized string functions. So what I'm going to do, I'm going to pull data text. I'm going to split wholesale, right? So to access these string functions, I need to use .str, which will give me access to all of the vectorized string methods in pandas. The split is called split. They're the same functions as the Python built-in string functions. And you can see that we got a list for each one of these texts. Next, I need to call the function len. So here, what I need to do, I need to access str again. Why? Because the result is a series, and there is no function len in the series. Len is bundled in the string methods, kind of submodule, so we need to explicitly access that and call len one more time, and we get the length of each one of these earning calls. So the result is the same, and I'm going to assign it to words, and this operation does not change. So we get to the same result, right? So either using a function that we write and we apply it on each one of the strings, but if the function already exists in pandas, we can call one, or in this case, the two functions, the vectorized string operation functions. Okay, so let's take a look at the second question. The second question is asking us to count the number of companies in each stock exchange. So if we look at the text, you notice that in each earning call, probably in the first or the second line, the first line, there is information about the stock market and the company ticker. Okay. Now this information is embedded in the text itself, so it's not extracted from the text. It's within the text. So we need to extract it first before we try to do any operation on it, right? So this question has two parts. The first part, we need to extract stock market tickers and company tickers. Company tickers are not really needed here because we have data about the company, but we can do that. We can extract the stock market ticker and the company ticker from the data. Once we do that, we can count how many companies per each stock exchange. Okay, so let's do it again using the same um, two strategies here. What we can do, we can pull data.ilock 0, 1. Okay, and that's the text, and we need to extract this part from the text. So there are many ways to do it. We can kind of deal with this manually because this is in the first line. So what we can do, we probably can peek at the first line and look at the first column. And then when we look at the column, we can pull the characters before it and after it. An easier way to do it is to use regular expressions, because we can write a regular expression and then we use this regular expression to search, kind of to sniff through the text. So we can do it using the built-in RE package in Python. We can do exp is re.compile, a certain pattern here. Alright, so we don't know what the pattern is yet. And then we can call exp.findAll or one of the functions match that will help us get the match from the text. So one of the regular expressions functions in Python. So let's take a look at the text again here. So findAll or match will help us here. Let's try findAll here. Well, first we need to write our expression, regular expression, before we do findAll. So the pattern we're looking at is a bunch of words, a bunch of characters, capital letter characters separated by a colon. So here is what I'm looking for. I'm looking for this. A bunch of characters repeated. In this case, they're from A to Z. And they're repeated at least one time. And then a bunch of other characters from A to Z also repeated. And there is colon in between. I can be more specific. I can say, well, you know what, there is a parenthesis before and a parenthesis after. Now I had to escape this because parenthesis, as we will see, has a special meaning in regular expressions. So then I can do exp.findAllTxt, and this will give me the matches in this text. Right? In this text we have two matches. We have NYSE Zoe and NYSE USA. Right? If you search for it, trust me, you'll find this one at some point. Okay, here we have the second match, and of course we're interested in the first one. Okay. So what's the meaning of parentheses in a regular expression? The parentheses in a regular expression will basically group the match, because here I'm interested in two things in this match. So I can group these entities that I'm interested in. Instead of getting the whole thing, parentheses, colon, letters, parentheses, by default, I got those broken down for me. So my job is now easier because what I'm interested in the first occurrence of this one. And then that's basically my stock market and company ticker here, okay? So let me isolate this whole thing in a function. Let's call it extract stock market and company. Let's call it extract text txt, and this one will take a piece of text and we'll operate on it exactly as we have done. I'm actually going to paste this code here. re.compile, result is this one, I have to be careful here, right? Because there could be no match, so I need to check, ensure that there is a match here. Because otherwise I will get an empty set of results. Try to index it, I will get an index error. So I'm going to do if result, which basically saying that this variable is not none, and if it's a list, it's not empty. So I don't need to do len greater than 0. That's enough. If result, I'm going to return result. In this case, I'm pretty guaranteed there's at least one, and pretty much guaranteed that I have at least one match here. Otherwise, I would return none, but you know that the Python functions by default, if they return nothing, they return none, so it's not needed. Okay, so if I do extract txt here, I get nyse. So what do I do with this one? Very much like we have done above, I can do data txt.apply extract text. Basically, I want to apply this function wholesale on the whole series, and I get my stock market ticker here. So what I'm going to do, I'm going to pull the stock. I'm going to save it in text. Let's do this. Stock is this one. So do data.head, see what we've got here. And this is the stock. Next, it's basically asking me to count how many companies we have in each stock exchange. Now we have the company name here, right? There's a slight caveat here, is that this company name here in our data is unique. We have an earning call, we don't have two earning calls for the same company. So we can do something like this. We can do data dot group by stock and then count. Okay, basically, or pull the company and then count. So you can see that we've got 6 companies in NASDAQ and 4 in New York Stock Exchange. So that's fine. It's possible to do this here because we have a unique company. We don't have 2 earning calls for the same company. If we had 2 earning calls for the same company, then we have to be careful not to double count the same company twice. Okay? So if this is the case, then we need to be kind of a bit more careful about doing this. Okay, so let's do this using the vectorized string operations. What I'm going to do, I'm going to pull text, access str, and then call the function find all, and supply my pattern here. And lo and behold, we get the same result, same answer. And then what I need to do next, I need to get the first entry from each one of them. So str 0 or str.get0 again. And then I need to get the first entry of each one of them. So str.get0 again. And this is basically my stock ticker. I can put it back in the data frame and do basically the same thing. Nothing will change beyond this point. Same result. Okay. We can also do extract. So find all, as the name implies, will find all of these occurrences here. Okay, if we do extract, it's going to extract the first match, but it's going to extract these groups to different columns in a data frame. So what we have here, we have a column per stock exchange and a column per company. Okay, and we can rename these if we wish. So we can do something like set axis and rename the columns, or we can go with the default names if we're just interested in these. We can do group by 0.count. It will not be as nice as the previous output, because 0 and 1 means nothing here, uh, but basically give us the same answer. Okay, so the third question is, what are the top 10 most frequent words? So this question is basically asking us to operate on the text and count the number of words in the text. So let's do that, and let's do that again using an individual observation and then apply it wholesale on the series. So that's my text, and if I want to count the top most frequent words, we actually have done this before. So remember when we've done the dictionary, I'm going just to type it very fast, count words. We've done this method in a previous exercise. It takes text and then puts the result in a dictionary. And then we split the text and then we initialize the dictionary for each word in words. We need to initialize this to be 0. To be 0. And then we do this again, word in words. We now increase result word is equal to result word plus 1, and then return result. So the first loop ensures that we have an entry per word. The second one goes over these words again and increases by 1. Well, this one is making some redundancy because some of the words we're going over them twice and reinitializing this entry as 0, so it's not a big deal, but if we want to be more kind of minimalistic, we can do set word because we want to do this once per word. So count word text is going to give us this dictionary. So we're not there yet because this is asking us to count the top most frequent words. Okay, so we need to do the most frequent one. So let's do top frequent, and then by default I'm going to pull 10. Oh, we need the dictionary here. The count. Call it word count. So what do we do with this dictionary? Well, we need to sort it, right? So we need to sort it. Let's save it here. Let's do wc is equal to count words txt. And then if we do sorted wc, it's going to sort the keys in the dictionary. So that doesn't help us here because it's sorting the keys, and I want to sort based on the values. Okay, so there are different ways to do it. Remember that the sorted function used to take a function called key, and this key function will be used to sort these values. So instead of sorting by default on the dictionary, we can sort on the value associated with each entry in the dictionary. So that's our dictionary, and then we can get the items here, and then we do sorted wc.items. What the difference is that the iterator will not go over words, it's going to go over the word and the value, the key and the value, but it will still sort based on the key. We want the sort to be on the values, so we can do keys lambda x, and each x is one of these tuples, right? And I want to do x1. Well, the sort should be also descending, or for easier access to the top word, I'm going to do minus x1 to reverse the sort order. And this will give me access to the sorted list of tuples based on descending order. So this is what I will do. I will do sorted top frequency. I'm going to do the following. I'm going to copy this code. We'll make sure that this is word count, not WC. Make the sort. SWC for lack of better name for now. And then I want to return SWC from the beginning to the end to n, right? Well, let me first ensure, well, so let's try this one. Let's do top frequency of text. Let's see what we've got here. Incorrect. Word count. So top frequency of count words text. So we get the top 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's right, that's correct. But we're not getting a dictionary here. We're not getting the words. We're getting like items. Okay, so I need to convert this back to dictionaries and get the keys from it. Okay, so I can do this here. I can do dictionary of this. That will give me the dictionary, and then I want the keys. That will give me the keys. Or I can return the dictionary if I'm interested in the values as well. Okay. We need to be careful here because, say for instance, you request the top 1 million words. They're not so, oh, they are. At some point, you may risk getting an index out of bound. I'm not sure why this is not creating an error here, because I don't think we have that many words in the data. So something here is my guess is that the dictionary, the items object is smart enough when you index it not to go over the indices. But let's see. So this thing looks like a list, but most likely in reality it's something else. So no. Alright, looks like the slice operator is smart enough to stop the slice when it's going out of index. So I learned something new too. I was thinking of putting an if statement here, but it looks like it's not needed, so let's leave it as is. Thank you, Python. Alright, so we've got our function here. And what do I need to do here? I need to do the most frequent words in all of the earning calls. So now the order of operations here matters a bit, because if you do this on each one of the text, the data text dot apply count words, and then dot apply top frequent word, you still need to add the counts together. And this is another operations, because once you add the counts together, maybe the count will differ, right? And this is a bit cumbersome because there may be a word that is not in the top 10 in each one of these, in all of them, but if you add the counts, it's maybe one of the top 10 words. So instead of doing this, I'm going to join all of the text in one big text and pass it to count words and top frequency. So what's the operation? Well, the operation is sum. Sum is going to sum all of these in one big gigantic text. So the only problem in sum is that it's not going to put a white space in between these things. So what I'm going to do, I'm going to add a manually white space upper in the beginning, at the end, and then apply sum. And that's kind of the big text that we want to call to count words. And this will count the words and top frequency to top the word frequency. Okay, So those are the 10 top frequent word in the text. Now, if you look at the solutions I posted online, I used a class called counter from collections. And counter is basically, as the name implies, counts items in a sequence. So if you do counter txt, is going to do this for us. Oops. txt.split, because it now counted character. It's going to do the text count. Okay, so counter will make things a bit easier for us because it's going to do the count. Well, basically, it's doing this operation that we implemented manually. Okay, so instead of repeating the whole thing here, I'm going to use counter for the next exercise. Okay, so in this exercise, it's asking us to report the 10 most frequent words per sector. Let's do it first using what we have, and then do it using counter. Okay, so let's first try to use top frequency and words. Now I'm going just to use a function to embed this one, def count, well, I'll call it frequency of text in series. So this one will take a series, and then I'm going to do n here. I'm going to pass the same n to that same n. And what it's going to do, it's basically going to do this. Instead of data text, it's series. Top frequency. Okay, n is equal to n in this case. So why am I doing this? Because I don't want to repeat this thing again, and I want to group it by sector. So now if you do frequency of text in a series, you can call it in using the series. That's basically the same result we got here. But the question is asking us to report it by sector, which is not a problem because you have your function, so now you can use it, you can apply it wholesale, right? Pause for a minute and think about how you want to do it. And I hope the answer is using group by. I'm going to group by sector, and I'm going to pull text from the sector. We've got the group by object here. Let's peek inside it and see what we've got. You can see that for sector, which is capital good, we've got this big text here. And here for consumer service, we've got this big text here. So they're not very kind of a clean in here because the text itself is very gigantic. But for capital good, we got only one text. For consumer services, we've got 1, 2, 3, 4, and those are the indices from the original data. So the first observation comes from consumer service, as well as the third, fifth, and eighth observations. So what am I going to do with this one is, because we've got a series in each one of them, I'm going just to apply frequency of text in a series, my function. And this basically will do the magic because it will apply this for each one of the series in my data here. Okay, it looks like there's something here resulting from those NA. I'm not sure exactly what's going on, so this is something worth looking at. The off and to our that. I'm hoping here I didn't do something because I'm getting the same results for each one of them. I'm suspecting now of a copy-paste mistake at some point. Because those are the same result, same text. Now, it can be the case that we're getting the same text for each one of them. The word count here is the result of calling dot sum series plus. So I'm not sure if it's because it's aligning these indices. We're probably getting NA because they exist in one and they don't exist in the other. The numbers can be still correct. So let me do this manually. Let's do list. Let's unstack this one. It's mostly because it's aligning the indices. I'm going to unstack the first level here. And because it's aligning the second level, the index, we've got none on A. So is not among the top 10 frequent words in the first one. Let me try to do it using counter, see if we get similar results here. So from collections, import counter. And the function here is the following. I'm going to create a function called top 10 for the sake of simplicity, and this function will take a series and it's going to do the same thing. It's going to collapse the text. So text will be the series. So let's call this one S plus a space dot sum, and then I can do a return counter of that text. I'm just testing it, so I'm going to do top 10 of data text here, and I should get that sorted out. Now I forgot to split, and this is why we've got the characters by the character, right, rather than the word. So I'm going to do this. That's my counter, and then I need to sort this thing again using either sorted. We've done it using sorted, or we can sort it actually using pandas series. So because this one is kind of like a dictionary-like, I can pass it to the series and I get myself a series, and I can do sort values. Ascending is false, and then I can go from 1 to n to 10 here. That's the same idea, right? So what I'm going to do here, I'm going n is equal to 10. I'm going to do this count is counter text, this guy, and then I'm going to do return the series pd.series, this guy count, sort values 10 to n. So I'm going to do here top 10 data text, and I should get the same result. Okay, so next I'm going to do group by sector text, and then I'm going to apply my top 10 function. And here the top 10, this one dropped to the NA. Let's unstack, see what we get here. And we got the top 10 here on each one of them. This one we've got a 12, so for some reason it aligned the index and we get not a number. But we do that here. So I'm still unsure whether there is something, because I here is NaN and is NaN. No, we basically got similar results. In both cases, it's aligning the index, and we've got not a number in some of them. All right, I hope you enjoyed it. This shows you the power of using vectorized string operations in pandas.